I'm not going to stand far away. So, more on it. Let's start.
A very good morning to the gathering present here. It is my honor to introduce Professor Suresh Sundaram sir, Chair of the Robert Bosch Center for Cyber Physical Systems and Professor in the Department of Aerospace Engineering at IISc Bengaluru. Sir holds a PhD and ME in Aerospace Engineering from IISc and BE in Electrical and Electronics Engineering from RPR University. He has previously served as the faculty of Nanyang Technological University, Singapore, and has gained rich international research experience at renowned institutions such as France, Korea University. With over 400 publications and a book to his credit, he is also an associate editor of leading journals including IEEE Transactions on Neural Networks and Learning Systems. His research expertise spans intelligent flight control, autonomous systems, applied game theory, computer vision, robotics, and AI-driven machine learning. He has led significant initiatives such as the Wipro IISc Joint Research Program on AI-based autonomous systems and has developed impactful real-world applications, including drone swarm systems for forest fire mitigation. We are privileged to have you here, sir, and also a warm welcome to everyone. Over to you.
Very good morning. Can you hear me without mic?
Yes, sir.
You want to record the voice?
Yes, sir.
If you want to record the voice, I'll just do it.
No. It's
No need. See, I prefer because that will limit me to move around. Before I start the talk, I just want to know what kind of mixture of faculties we have here. How many are from computer science background? Okay, so how many from electronics? How many from electrical and mechanical sciences? Great. Good to see at least a civil. Oh, great. Good to see a mixture. My talk is going to be different, so pardon me if I use any way. I'm not biasing with the gender or any of this because I just want to connect and make you learn better. So if we give some examples, just make you understand. And also apologize, I'm a professor, so I sometimes ask questions, so I want an answer from them, whether it's a student or my colleague. So bear with me, and then more interactive, then it will be fun to learn, otherwise talk will be monotone. Okay? And this is a very interesting area. They gave me a very interesting topic to just talk about what's going to be future. They say future of generative AI. I took a liberty of removing the word generative AI. I thought I'd just say future of AI and career pathways, right? Particularly research is where I'm going to spend a lot of time because all of you are faculty. It's better to just focus on research. Any students are there?
PhD students are
PhD students, right? But you're planning to get into academics or in job? I'll touch base on that also. Research is more on AI. Oh, fine. So I'll try to spend more time connecting problems in engineering domain, how AI is going to play an important role on this. Okay. When I talk about AI, what comes to me is some questions on intelligence. Right? Can you tell me what is it? How do you say it's apple slice? Shape? Is the apple is of that shape? Apple is of this color?
When we peel the skin of the apple,
Even car is of the same, right?
with the previous experience, we have noticed that.
Previous experience you have noticed, but you are right. I am not saying you are wrong. I am trying to understand why it is an apple slice.
She's telling cashew.
Cashew could be correct. There's, see, nothing wrong in it. Right? But you are saying it is an apple slice, it's correct. But why? How? See, intelligence, you use intelligence all the time to identify. But can you tell me why it is an apple slice? It doesn't have the shape of an apple. Right? It doesn't have the color of the apple.
We had seen.
You have seen, but tell me what is that? My question is, you have seen, you have learned it, your experience, learned it, perfectly fine. What is that apple for you?
Object.
What's the object for you? Right? This is also apple, correct? This is also apple, correct? This is also apple, correct? And that's also apple. Right? This is also apple. Right? Then what's an apple for us? See, intelligence always comes with a concern. Right? What's an apple for us? I'll connect you. Generative intelligence is much more challenging. But can you tell me what's an apple for us?
Based on the semantics, with different context, we need to take the meanings.
Can you give me more clear semantics you are saying? Can you give me what is that semantics helps you to say it's an apple?
In what context they have used with the sentence previous.
I can understand all of this, right? But my question is much more fundamental, right? What's an apple for you? I told you already, I'm a professor. I will keep asking a
It's an
question.
image of apple.
So daily we have to see that
No,
we have
you said fruit. The question again, I'm directing you in one direction, right? The worst part of a professor's, right? All of you know, you agree with me, right? Unless you give me an answer what I'm looking for, I'm going to keep asking a question, isn't it? Right? So I want my answer instead of looking for. I'm telling you, said fruit. Is all fruit an apple? Then what's an apple? You have trained with an image. Most of you have kids, right? Younger ones are also there, right? Do you show them image to train them as an apple?
daily used to bring to home now when we cut, we will show them.
Do you show them and say this is an apple? Beta, this in this semantic of a plate, I am keeping it. Do you say any of this?
No.
Then what's an apple for him? Help. No, not all objects are apple, right?
Some company name is there also.
Correct. Not all companies are apple. That's
Depends upon if you are drawing on a paper, it is an image. If it is eatable, it is an apple. Otherwise,
hold
it
on,
is a code.
hold on, hold on. You say eatable, right? Not all eatable is an apple. Then what's an apple? See, one of the questions to me is research, right? I am asking a question, intelligence first, right? Intelligence is, we all know it's an apple. That's an intelligence you all have. There is no question on that, right? But you all don't know what's an apple, that's my claim, right? I'm trying to figure out, can anyone give me an answer of what's an apple for you? If you say fruit, problem is not all fruit is an apple. Then what's an apple?
We will try to describe the features of the apple, the
Hey,
shape,
tell me.
color, when we peel and inside the
Let's go one by one, okay? One by one answer. Let's take shape.
shape.
Can you tell me apple shape?
Clear.
Huh? Is it somewhere nearly spherical? It's not even spheroid. Sometimes it just goes like this also. There is no shape. Fundamental shapes, what we teach? Circle, square, triangle, rectangle. 3D is sphere, cone, cuboid. Nothing fits here. Color. Good question. Tell me what color is an apple?
Red.
Not all red is an apple.
No, green apple is also red.
Apple can be red, green, reddish green, yellow, golden green. Right? It is not pure red. If you look at the pixel value, it is not only pure red, isn't it? Then what is red? See, I'll keep going, right? So shape is not an answer for me, color is not an answer for me. What is an apple then? Taste. Good point. Okay? Can you elaborate? What taste of it is an apple? It's sweet, right? Think about it. Right? Neither I am a Rama, nor you the Sabari. I take a bite and say it is sweet and give it to buy. Right? Then tell me what is an apple. Huh? Some of you might agree, right? You didn't buy an apple from a shop. Your wife says, buy an apple from a shop. You buy and bring it home. She kind of thinks, no, you are an apple, right? Isn't it? Now then what's an apple for us? Apple as a, why I took this, apple looks beautiful on outside, rotten inside, right? You'll never be able to figure it out from the outside. That's the reason I took that example. It's very difficult to figure it out whether it is rotten or not. Right? That's the reason we connect apple with many other philosophy in life. Right? Now you think, tell me, what's an apple for us? Right? Adam, you time out to use this as an example, but we never figured out what's an apple. Why I'm asking this question is your kid, let's say your son, kid, or whatever, daughter, kid, can recognize an apple before even knowing color, before even knowing texture, before even knowing shape. Right? Okay? Then what's an apple for that kid? Food. I put it that way. It's a food, right? Is all food as an apple? Then what's an apple? See, research is philosophy, right? I'm not able to figure it out. What's an apple for me? Right? Can we find out what's an apple for us? Think about it. She mentioned experience. Let me ask experience on apple. Before even know color and texture, the kid recognizes apple, right? What did you teach the kid?
No, gradually they pick up, not at once.
They picked up. At that time they recognized. Let's talk about that. 2-year-old child. Okay? Or 10 months, 11 months, they start able to put things on their own mouth by themselves. They can recognize. Right? You go sit with the child, cut a slice, and say, this is apple slice. Right? You have to take it and bite it like this. You have to chew like this. It has so much vitamin and mineral. Every day you eat an apple, you don't have to go. All this you say?
Yes.
Do you say all this? Oh my God. I would be really happy to be a kid of yours. My mother didn't do that. First time, vitamin, mineral, nothing, no. I'm just a kid, 2-year-old child. I would have been really happy to be part of your family. My mom didn't do it. My mom did a very simple thing. She cut, keep it in front of me. Right? You eat, she'll go quiet. You don't eat.
She will give it bite.
Simple, right? Not now for a 2-year child. Some of you will agree. Your mom mother does now, right? She keep a plate of apples, you don't eat it. Don't you know? Simple, right? She never explained any of this. Only one word is a feedback signal. That's it. What the kid does, takes an apple, look at her mom, she'll wait, look. If she's angry, put it in her mouth. She's happy, put it on the ground. Right? Now what is experience here? Tell me. Learning, right? What is experience here? Learning means we always say 1 + 1 is equal to 2. Right? That's what we mean learning. What is the learning here?
We're training the kid.
Training the kid for what?
He'll understand whether angry or happy.
The point is, angry or happy is not the way to figure it out on the context she was saying. Semantic question. You don't understand any of these, right? There is context or semantics. She doesn't even know you are stressed out because you made a upma in the morning. No. Right? Nothing is known. How am I learning? That's a point you have to figure it out, right? Intelligence is sometimes. So all of us know apple. Can I say so? All of us know apple, but none of us know what is an apple for us. You agree with me? What is it? We know that knowledge, but we don't know how to express it. Right? So that's what knowledge is. Right? How you acquire knowledge is different for different purposes. Right? Now I'll give you one more knowledge. Okay, where you can explain things, right? But you don't experience it. What will happen if how many of you touch the fire? All of you know cooking, I've been cooking at home, so I should ask this thing. Really felt of touching the fire. Not accidentally, purposefully, not accidentally. While cooking you will touch the fire. I'm not asking that question. Have you touched the fire purposefully to experience the learning? Why? Why you didn't touch purposefully? Question is why?
It will burn because it
It
is
will
not
burn, correct? Your answer is right. That before you accidentally touch, you know that it will burn, correct? It's a prior knowledge. Somebody said, right? You don't experience it. Jumping from the top of the fourth floor, right? Will I have to experience? If I experience it, what will you say? You're a crazy man, right? So, not always, all knowledge are by experience. Isn't it? Do you agree with me? Some of carry forward. Right? Now, the most fundamental question. Kid was born out. Immediately started crying. Who taught the kid to cry? Everything is learning. Who taught the kid to pray? There is something called residual knowledge which is present in every one of us. We use that term to scold others also. What is that term? You make one mistake, a stupid mistake, like touching a fire. What is that in the mom will say? Huh? How do you scold your child if his son comes purposefully touching the fire? Stupid is something you just think. It's a common term we use. Don't you have common sense? Right? So you think about it, common sense is a knowledge, right? It doesn't require experience. Right? It's also knowledge. But if you go and ask God, how far I can go closer to the fire? That's an experience. Depends on your tolerance level, right? Start cooking very first day, touching a hot vessel is difficult. Over a period of time, you know the best way to pick it up, right? So that's the experiential knowledge. How close I can go, what is my limit, how far high I can jump, right? Without hurting myself. That's an experiential knowledge, right? You understood between a common knowledge and experience knowledge, but still we have a problem. Problem is, we are not able to explain what is knowledge for us. Simple. Expressing what is knowledge is a problem. Why is a problem with that? Because artificial intelligence is all about that. Why is the problem? The biggest problem is language. Right? English is not my mother tongue. Right? I don't know how to express what is there. Kannada may be a mother tongue, but I don't know the words to express it. Right? So knowledge many a time not expressed properly because we don't know the right way of conveying what is apple for us. That's it. Simple. All these color, texture, shape is being told by someone. Right? We are just following. But you tell me bottom of the heart, I will close your eyes. Right? The moment I close, you can't see the color. Right? I can remove the layer, the texture is gone. Do you agree with me? Color is gone, texture is gone, right? I can even stop putting something closer to you, even remove the spell, but still you can say it's an apple. Right? Then what's that you are looking at to say it's an apple? You understood the basic problem, right? What we have, the AI what we have today is very mundane. Okay? It's not intelligent at all. Long way to go. Okay? Very long way to go. Now, I'm going from AI to generative AI. Okay? Don't take, see, I use certain words stupid and mundane because I just want to give you a connection, very easy for you to connect. Let's look at a generative AI. Okay? I asked you to think, right? We always say lateral thinking. You should think laterally, right? Generating AI is what it's able to think laterally to come out. Is it thinking laterally? You ask AI to generate a car. We'll put a car in the wheel in the front. Will you agree? Wheel in the front like this. Will you agree as a car? Why not? Problem 2 what? You want to go front, you see a wheel here, you think the car cannot function. Correct? But what is a car for us? Moving from one place to another place is a vehicle which can move, but you can just drill down a little bit and tell me. Car means there should be a wheel, there should be 4 wheel, 4 door or at least minimum 2 door, 4 small windows, front rear mirror, back. That's your definition of car. Correct? You fed that information to the AI. So what AI does? You want a wheel, I'm putting you a wheel. Right? You want a window, I'm putting you a window. Simple. But you are not accepting that as a car. You understood the problem. You are never able to tell what is actually car for you today. Right? So how is generative AI going to work? You see a problem? Chat GPT. Okay. Let's look at GPT. Let's talk about all the problems because my objective is to talk about research. Right? Let's talk about the problems first. Large language models, you can just beautifully talk about it and all this. Do you know there is a chat GPT exists before even chat GPT? Before even computers being invented, there used to be a chat GPT. No, we are not that good. There is one person, one particular job. No. ChatGPT doesn't only do translations.
Chatbot.
Huh?
Chatbot.
No, I'm talking
No, all
about
the
much
questions are
earlier.
very different based on the data.
I'm even talking about before the invention of computer. There's a profession. There is a program also, information science we talk about, right? Information science is what? It's all about information collection and all that. Who is the person who collects all the information? But he's not an expert in that domain. Library, for me. You go to a librarian, you ask, I want Shakespeare's book. She will tell you. Go to the 4th shelf, 2nd floor, top. Many students will just misplace it. It goes even further, right? Look at the bottom of the shelf. they might have kept there, right? Not only that, you bring a book to a librarian. No, you are reading this. This genre is very difficult for you, right? How are you understanding the genre? Right? It's more philosophical. Better read that book. Is that the ChatGPT? Exactly. You go in and ask her, how is this book? She will even give a gist of the book if she is not an expert at the domain. Right? Isn't that what ChatGPT does? Just the information, right? Now I'll tell you, humans are much smarter. Okay? Someone comes to me and say, I OTP you. Can you tell me what the meaning of it? I OTP you. Sometimes it's annoying, right? When you are talking background. Maybe you can ask the student to keep quiet. Start there.
Sure, deeply for that.
It's fine. I'll use the mic. Don't worry about it. I'll use the mic.
5 minutes.
No, no.
45.
I understand. See, we'll adjust. No, don't worry. We are talking about library. I OTP you. I OTP you. Can you someone decipher the sentence and give me the meaning? I OTP you. Can you tell me? Somebody comes to you and says, I OTP you. What do you think of it? Why you should OTP me? OTP means what? One-time password. Why should I give it to you? Think about it. What is why OTP? One time? Context is very difficult to figure it out, right? I OTP you if your kid says to you, she means over the phone told you. It is generation Z. Now think about generation data, how you have talk. Our own kids, right? Look, never figure out. I will send you a video. If you hear it, you can understand how slow you play. You will never be able to understand because their jargons of communication are changed. You all agree with me? Right? That's a communication gap. Communication is the biggest reason you are not able to understand the intelligence. That's what you have been talking about. Now, what does that do? Think about a philosopher, right? I'll give one more example of philosophy. Some of us are doing research, right? Research means you need to express something in one word, one line, one page, or thousands of pages. That's why you are called philosopher, right? That's why I'm giving you philosophy. You all know Ramayana, Mahabharata, correct? Can you tell me in 3 words, what is the story of Ramayana? Or 2 words. See, probably I use Tamil to express. It's easier for me. I can say it in 1 word in Tamil.
Rama Sita.
Doesn't tell you the gist of Ramayana, right?
What is that?
Ramayana in 1 word. Ramayana, Mahabharata in 1 word, right? It has to tell the whole story. We all talk about that, right?
Just for land, just for
It's not coming together. No? You are right, somewhere nearby.
just for one girl, one lady there.
What is that? Manasa. Man means land. The love towards land led to Mahabharata.
In Kannada,
Right?
you know what to
Love
do.
towards a woman
Soil.
led to Ramayana. Right? Such a gist of the story. Now I can expand and talk about 1,000 lines. Thousands of stories. Put together saying one line.
Sir, in Kannada we say Ennu, Monnu, Monnu means gold.
Yeah.
Everything it happens because of these 3 things.
language is a problem. That's why I use my mother tongue to
Yes,
express
I got
it.
it.
So you understand the knowledge really means here. You are able to abstract your power of knowledge shown only by language. Right? So ChatGPT looks beautiful because that's the language power. Right? It's nothing but my library for me. Okay? Now you tell me, I want to create a story. Write a story. Right? Creation. Right? Creative thinking. Right? Let me just go one level down. Say, I may go a little longer. Please stop me if I have to stop somewhere. Okay? Otherwise, it will be a big long lecture. Okay? I am not even crossed the first line. Okay?
Can I provide a color light for you, sir?
Just give it. Is it fine?
I understand.
Yeah. But this song only comes from here, no? It's fine, sir. I think it's fine. No problem. No, again, this will be here. Right? We will discuss. Where someone comes and discuss. Otherwise, you have this. You are talking about Ramayana. Thinking. Can you somebody tell me what is lateral thinking? Lateral thinking. He always says think different, think out of the box. Right? Tell me what is lateral thinking? Out of the box. What is that out of the box I should think? First of all, I don't know what is lateral thinking itself. Right? I'll tell you a story. Okay? It's a real story. He got a Nobel Prize, that person I'm talking about. He's a student of the Nobel Prize winner also. Right? He was in engineering college. Right? The physics teacher is talking about pressure. Right? You can use pressure difference to measure the height. Right? Difference pressure is proportional to the height. Right? So everybody knows it. Then he asked a question in the exam. How do you measure the height of the building? Okay? Tell me what that. We measure the pressure at the bottom, go to the top of the building, measure the pressure, difference in pressure proportional. Here, isn't it? Simple answer. The student wrote, I go and wake up the janitor. What should I find this stuff? I'll go wake up the janitor. Janitor is someone caretaker of the building. I'll ask him what is the height of the building. He will say, and that's my answer. He will tell me what is the mark you will give. As the teacher, you tell me what the mark you will give. 0. Right? You cannot give 0 mark because he is a top student. Hence, he gave 0. The student went and complained to the. If you give 0, what the student will do? He will go to the headmaster. Right? And told the headmaster, see the teacher is giving 0. He said, what the height of the building is a question. After he gave is not correct. Isn't it? How can he give 0? Now, what the headmaster will do? What will you do? I'll set up 4 faculties to evaluate. All of them combine the answer is right, but it's a physics exam. I'm looking for answer in physics. Right? They call for a meeting. They call the student and say, see, your answer is correct, but the physics exam, but it's a physics answer. No student said, you want a physics answer? I give 1,000 answers. Don't give me 1,000 answers, give me 1 answer. That's what Professor got irritated because of all this. Give me 1 answer. Right? And that's with the the pressure measurement device, right? No barometer, no problem. Take a barometer, tie a thread, go to the top of the building, let the barometer goes down all the way, touch the ground. You know the density of the thread. Measure the density minus the height of the barometer. Right? Density, with that you can measure the length. Right? You know the volume, you know the diameter, you know the length. Length plus this is your answer. Go and stand in the sun. You take a vitamin D. Is the answer what he said? I'm just saying. As much as possible in the bottom sense. Right? You see the shadow. You see the shadow of the building. Measure the shadow of the barometer and measure that. You will get the answer. Right? Or you go to the top of the building, take your stopwatch, let the barometer go. When it hits the bottom, you measure the time difference. With that, you can measure the height of the building. Right? V square plus V square equals U square plus 2AS, you find the answer. Still physics. Right? The poor barometer breaks. You want a mundane answer? Measure the pressure at the bottom, measure the pressure at the top, the difference in pressure is proportional to the height. Right? That's the level of thinking. For every problem, I have a multiple solution. The best solution, best answer would be hand over the barometer as a gift to the person who is taking care of the building. Right? Ask him what is the height, he will tell me the height. So what the intention of the student is different. He gave me a problem, I have 1,000 answers for it. 1,000 way of solving that problem. Right? That's what we are asking for. Don't tell me the conventional way, I am looking for something different way of solving it. Right? That's what we meant, out of the box thinking. Simple. Find out who is that person. Okay? If you know, let me know who is that. You got a Nobel Prize for physics. Okay? Find out. His teacher is also got a Nobel Prize for physics. Find out who is that person. Now, all these you look at it. Right? I'm going back to agriculture. Newton says I found a gravity by seeing apple falling. Isn't it? Not connecting the dots, right? Is it connecting the dots? I keep seeing a lot of things falling down. You ever wrote a book saying that apple falling down is led to gravity? No. And you keep thinking about the problem of everything is falling down, why everything is falling down. Right? That's the intention behind it. So what I'm trying to say is a problem is something which will never make us sleep. Okay? It will keep haunting you till you find a solution. Right? That's the reason human has a pressure problem. Right? Anything is a pressure problem. Okay. Now, why I bring all these aspects of it when I talk about intelligence? Intelligence is connected with so many factors. I give another interesting example. You will agree with me that you are excited. Right? Super excited. When saying to be promoted, you are going to be the principal of this institution. Let's say. Somebody even call your name, you don't even recognize it. Right? Because of your excitement, even if somebody shout your name, you won't even turn on. Let's say you are upset. And morning you want to come to office, your husband says, every day you work. Right? Irritates you. You coming in the pipe, looks like everybody is calling you. Even smallest disturbance will make you upset. Right? Now what I'm saying, tell me, same person, same intelligence, everything is same, behavior is different. Right? Can the AI do such kind of things? No, right? So what we have is a very specific intelligence. I'm not saying that AI is not good. Understand what we have. AI can do very specific things. Doesn't have general intelligence. Right? The way I talk to you, or way you talk to your students, way you talk to your son in different situation, you change according to this situation. A semantic or a context scenario, what would have happened in the school, and where he went, what might have happened in the college, you think about it and you react differently. Right? So that's called general intelligence. Long way to go, general intelligence. Think about it. I have a robot. Okay? I put a robot to clean. Robot has air. Right? Means it has the ability to make decisions. Right? Even here, what we do. Let's forget about robot. Beautiful car, new model car, launched. Some of your colleagues have the car. Right? How you react? He is driving the car. You have a old vehicle, met with a couple of accidents. What will you do?
Very nice.
Huh?
We say it is very nice. Looking beautiful.
No, I tell you what I will do. I will go closer and see what he does. You go closer and put a brake. I am satisfied. Isn't it? Human reaction to anything is different. There is an autonomous robot here cleaning. And you say, my robot doesn't obstacle the water. It takes care of obstacle. What will your neighbor will do? First thing, stand in front of it and say, does it avoid? Think about it, I have an autonomous car, right? Is it standing in front of you? Does it stop? I'm just saying your son got a license. Can you stop in front of it? Him when he is driving, are you ready to stand in front of it? No. Our interaction with autonomous vehicles or autonomous systems changes completely. Isn't it? We are smart. How smart we are? You have Ola Uber, use the same phone to book. Price is different. Right? Use a different phone. The person sitting there is an intelligent person. He changes the policy too. You understand? System reacts based on data. It relies on the data. And the biggest question to me, what is the right data? Right? Data is the key for AI. So let's say I am building a data to solve cancer. Okay? Think about it, you are a computer science person. You go to a doctor. What will be your question? You want to solve cancer ka air. Okay? And you go to a doctor. What will you ask the doctor? Give me data, right? What does it mean? He gives a normal data, normal person ka data. What will he say? Give me more cancer data. Think about it from a philosophical perspective. More cancer in my society, is it a good sign? Right? Now, can I get something more data? Not possible. So, what is the right data then? I want to give this example with a classroom. You go to class, you teach a subject, right? What will you do? You plan. 5 subjects, 5 lectures are there, or 5 topics are there, I'm going to cover. Right? Every topic will give a question to the student. You often see many students doesn't come to the class. Right? You always have one smart one. You will never come to the class. You will never solve the score well. Why am I saying smart? He knows what to study, when to study, how to study. That's what we call meta-learning. The biggest problem is he knows how to regulate himself. He will go to the person who goes sincerely to the class, right? Just before the exam, tell me important questions. Tell me 5 important questions got to come. Don't tell me anything else. Right? That's it. Done. He will not even bother with anything else. He will just go and write. Right? Even if it is stupid. Right? For example, if you ask a question about a cow, he says, I'm going to write a story about the cow. If there is a tree, so clever enough, write about a cow and say the cow is tied in the tree. You have to give marks. Right? So what I meant is self-regulation. human has an ability to ask the question, what's the right data? Right? Think about an autonomous vehicle. I'm building an autonomous car and putting it on the road and say, I want to avoid, what is the purpose of the autonomous car? To take you from point A to point B safely. That's a very important aspect. Safe is a very important aspect. Which means what? You should not collide with anything. Can I ask the data, give me collision data? Collision data, which means I take a car, purposely collide, so that's a data, because I want to avoid that. There is no such data available, isn't it? And how will I build a day? AI need a data. How do the AI know how to react to this collision? I'll just give another example. Right? There's an autonomous car. There's a two-lane. One of the lane, there's a big hole. So there's a cross side. In the other lane, 3 workers are standing. I am in such a high speed, slippery road, there's no way we put a brake. Okay? If I put a brake, passenger inside will get injured. What will AI do? Will it put a brake? No way to go slow down. I made this point very clear in the beginning.
From that mistake here, we should update it.
It has to update, but what mistake it will perform? Will it put a brake, injure the passenger, or will it go to the other lane, injure the other 3 people? What it will do? Will not apply brake, go and injure the other 3 people. Will you accept that? Put a brake, injure yourself, will you accept that? No. No, I change the question slightly. Instead of 3 people, there is a cow. You tell me what will you do? Not the bull, cow. What will you do? Will you hit the cow or put a brake? Now change the question. It's not a cow, it's a dog. What will you do?
It will go.
You won't hit the dog. Right? Because of sentiment attached to, not religious, don't mistake me as the religious. I'm trying to keep you thinking, right? Now you see, do we have this data? Can anyone talk you this? You make judgment. Judgment of learning, right? What is right? What is wrong? Does AI have a judgment? No judgment. No sentiment. Right? Now how do you say it's an intelligence? So, understand, we are moving towards general intelligence. It's a long way to go. So, if somebody tells you, yeah, you're going to replace your job, don't believe it. Yeah. Long way to go. Now, ChatGPT, you ask the question, I'll also ask the question. What is the answer? You will do what is the answer I will do. Different. Why?
Based on the prompt, what you do.
Prompt, right? That's a new job. Prompt engineer. Isn't it? Prompt engineer is basically what is he doing? He is very good in language. If you are good in language, you ask the right questions. Correct? Simple. I show you a picture. Right? I ask you a question. What is interesting to you? Right? What will be your answer? You will 1001 answer. Interesting is different. Now, looking at this picture, tell me what is interesting to you. Smile. Somebody looks like you're still keeping an apple there, right? And you pick an apple there. I am with 1001 imagination, right? Interest is subjective matter. It is not just based on just a data. You understood? Right? So, new jobs will always be created because we wanted to do a mundane task which I want my intelligence system. The phone came into picture. Before that, we remember everything in the brain. Right? I just give one simple example to all my students. Okay? Hopefully you have not attended any of my lectures. Okay? I'm repeating again and again. Think about it. I'm going to teach a mathematics subject now. Will you be happy now? Now let me go very specific. I'm going to teach fourth standard math. What? No trigonometry. Fourth standard addition math. Will you be happy now?
Yes.
No. Or yes?
Yes.
She says yes, so let me ask you a question, okay? 4-digit addition. Addition goes. That's it. 25 plus 25.
50.
Oh, good, but let me test. Everybody should answer, otherwise I'll teach math. I'm not joking. She said yes. I'm assuming she represented everyone. Everybody should answer. Eh? Answer correctly. Fine, otherwise no lecture. I'll stick to math. Okay? One more try. Okay? 125 plus 125. You have to answer very fast. The final question I'm going to do. Based on that, I'll decide. Okay? 1020 plus 1020.
2040.
Plus 20.
2060.
Plus 20.
2080.
Plus 10.
2090.
Plus 10.
3000.
Very good.
What was it?
So shall I take math class? What is the mistake? Can anyone explain why we said 3000? We are being taught to carry the nearest integer. What is the nearest integer here? 3000. Because you are not saying the 100. If I say 2090 plus 10, you would have said 2100 because the 0 was set. Right? Then you didn't say 0. Because nearest integer is 3. 2, just add 1 to it, make it 3. Does it mean you go back and practice 2090 plus 10 is 2100? Not 3000, 10 times? No. Right? What does it really mean? We know where we get silly mistakes. Right? These are what we call edge cases. Right? Knowing ability to learn, I am playing the question. You understood? I know what is the student's ability to learn, what I taught. So I ask a question with a twist. You make mistake. Simple. This is what we do in every course, every subject, every question. See, this is what we do. Right? Logic is that. That's the data. That data is there, you can do well. Does it mean you answer all the questions? No, you answer 2-3 questions, you understand the teachers, how he will test, you won't even bother about it. Right? That's called learning. So, what I meant is, the learner selects the data to learn. It chooses the data. The data gives me a right knowledge. Does current learning does that? No. Right? The biggest problem with the current learning is we make an assumption. The fundamental assumption we make, data, whatever I have, talks about everything in the world. This is not true. What we call in a mathematical sense, it is uniformly distributed in the entire space. Does it really uniformly distributed? No. Can you guarantee it? No, there are so many edge cases. I gave a live example of addition. Right? I can twist so many questions on the same level to make you mistake. Putting up pressure. Right? Just because of pressure you made a mistake. Isn't it? So simple. So data is not uniformly distributed. Whatever I sample, does the sample represent the entire distribution? Not really. You use this sample to generative AI and ask the AI to generate something, it will only generate that. Right? What bias I'm talking about? There are two types of bias. Because I collect, let's think about it. Okay? I collect only Kannada data. No other language. Right? Build a model out of it. What will happen? It will be biased towards Kannadians. Doesn't even bother about anybody else. Is that AI is the right AI? Ethically correct? No. So, representation of knowledge is also biased. So you need to take care of it. Data is the key. Data should represent everything. Otherwise, the model that you build out of the data is biased towards this particular space. It doesn't represent everyone. Right? I'm going to decide whom to get 1,000 rupees, the scheme at Kannada government announced, based on the sample that I have. Many will not get it. If the data is not uniform, they will not get it. Right? You understood the problem? Bias. Right? Model get bias. Now, second problem. Data is mine. Right? I don't want to give it away. You are all giving your data just like that to Google. No engineer or no engineer. Right? Google knows more than your family member. You get into the car, connect your phone, it will tell you it takes 20 minutes to reach your college. Isn't it? 4 o'clock, you connect your phone, you say it will take 30 minutes to reach home. You go near the Orient Mall and tell you today this particular your favorite stop, food stop, the hotel is closed. Your mom even doesn't know. Right? It will tell you based on your social network, it will tell you your friends are here. You like it or not, it gives you data and bias it. Right? So data is the key. Moment ownership of data comes in. What will I do? How do I make my model better? He says, I will not give the data. But I don't mind giving a model. Because model doesn't give you the data. Now, how do I use the model? Use my data to learn further. Right? That's what we call continual learning. Learning continuous. See, learning continuous is the biggest problem. Why? Why many students is not able to write a GATE exam? Is a topper in that semester, topper in the second semester, topper in the third semester, but when you say I put all of this together and I'm going to conduct an exam, he struggles. Because when he comes to the fourth semester, he forgot about the subject. Because he is not using it. If something is relevant and he is applying it, he is using it. If he is not using it, he forgets. Right? What does it mean? Continual learning will lead to forgetting. Right? Catastrophic forgetting, which means the model he generated with this data, I took the model, I modified in my data, I forgot this data. What's the purpose of that model again? Bias. Isn't it? So that's a problem. Continual learning. Now we talk about all the edge cases, right? All edge cases, data is very difficult. What we will do? We generate the data, right? How do you generate the data? We'll go to generative. We'll ask generative to generate the data. Just as close as possible. I use the data to learn. Tell me, if the generated data is close to the real one? No. There are problems, what we call domain gap. Right? Simple logic. In US, there is an autonomous car. Think about it. Let's say I'm a millionaire. Not impersonating. Suppose I'm Reliance son or something like that. I can get the autonomous car. Think about it, the car has to go out of this campus. Can you take me home? In Bangalore Road?
No.
No way. It won't even leave your car park. Right? We don't follow any rule. There is a U-turn, you'll be always starting from the leftmost side, without indicator, will turn. Right? You put a right indicator, go straight. Right? Sometimes you just slow down and accelerate, you don't know why you are slowing down. On top of it, a BPMT has an additional problem. Bump. There's no standard. Think about those bumps, what happened to those cars? It doesn't know whether the elevation is suddenly changed like this and goes like this and dropped down. No indicator. How does it know there's a bump? How does it know there's a pothole? Right? You will be going on the road, suddenly you will see the opposite side one guy will be coming. He'll come around side. Right? You know it's a one way. But still he will come on the opposite side. You bother about it? You don't. Still you drive. But this autonomous car will go crazy. Right? It doesn't know if it's doing a right thing or a wrong thing. Right? So that's what I'm saying. Data which is used there doesn't fit in. Let's take your son studying here, he has a driving license in India, he goes to US, he drives a car, he doesn't make mistakes. Right? So the domain we are very good at it, adapt. How do you bridge the gap? How does the model, which is developed based on the data in US, when it comes to India, it's failing? Right? But a driver who got a license in India is able to drive there. Or vice versa. Right? That gap is a problem. Then we are going to talk about all of this in this lecture. Yeah. Okay, I generally, but anyway, all you know perception and all this. You know who is this person? Any guess? Abraham. How do you know this? No, seeing the picture, right? What computer sees this number? Right?
Intensity.
Just numbers, right? I will not even talk about it. I go to Matrix theory, the famous movie, right? Just sees a number. Nothing. Now you tell me, computer made a decision. This is Abraham Lincoln based on what? We can do inverse convolution and say this is focusing here, right? We can say no, I can see a convolution there. I do an inverse. I can see it focus on eyes, focus on nose, focus on ear, and say it's a human. Correct? What's a human for us? 2 eyes, nose, 1 mouth, and 2 ears is a human. Spatially, they have to be in the same location. Think about it. 1 eye here, 1 eye here.
Position.
We don't mind having 1 eye here, except as a Siva, right? Otherwise, it's a demon for us. Isn't it? So, spatial connectivity also matters a lot. Right? We don't know what it is. We accept because it just solves my problem which I don't want to spend time on. Right? So I always give this philosophy. Don't worry about these innovations. The innovations help us to do much more innovation. In the early man, when he came out of the cave, he started eating the raw meat. It takes time for him to eat the raw meat and just rest a lot to digest it. So he can't think anything. The moment he knows how to make fire, he has time to think something. Right? The moment we know how to reach a place very fast, he can do more about it. The AI leaving a certain part of your brain free so you can think much bigger. Okay? Now, why I just brought this picture also? It's still a cat, right? For us, isn't it?
Yes.
We are always say head should be in the front, then your limbs should come. But head is in between the limbs. But still a cat for instance. If AI did not see the image, what AI will say? It's not a cat. Isn't it? So deformations, they are needed. Otherwise they can't pick it up. The scale data is needed for me. Eh? So AI has come a long way, but still this problem is a problem. All these are chats. Okay? The younger ones, the question I'm just asking, have you seen bike, what you call moped? Do you know how does moped look like? Have you heard? It gives me 75 kilometers per liter. Right? You used to pedal it and it starts. Right? Black color one, it doesn't exist anymore. Some vanishes, new things comes. I thought mopeds are all gone, no more mopeds. Suddenly it's electric scooters are there everywhere. Chaos is there. What is the rule of the game? Your vehicle, you should park in parking area. Now you rent a vehicle, where do you park? You rent a vehicle, where do you park? Whenever the time ends, wherever you are, you leave it and go. Correct? Where is the rule? Many times I'm seeing in a highway, bridge, there is a vehicle. Road, there is a vehicle. And I see a big truck comes at the middle of the night collecting all these vehicles and go. Who's the change? Isn't it? Long back when I came to Bangalore, I'm talking about 99, I'm proud to say that in Bangalore, they go by meter in the hotel. Even in the middle of the night, they'll say the property is 1.25 times. They won't ask anything more than that. But if you go to Chennai, there is no meter. Right? Now you tell me, same distance from this college to IIC, for you one price, for me some other price, for him some other price, they're okay with that. Right? Because he's a frequent user. Frequent user or not, whatever it is, price is the same. Where is the use? Right? You understood what I'm trying to bring up, right? Now, AI can collide among themselves. What I meant is, there is a book, okay? I'm not telling a joke, I'm talking about a real data. There is a book in Amazon, okay? And the hard copy of the book has been stopped around now. You have only soft copy. You can read only in Kindle, right? The price was $10. Okay? Only 2% have the book. One guy, philosophy is 1 rupee more than market price. Okay? $1 more than a market. Other person's business idea is 10% more than a market price because I want to have some profit. Okay? That's the idea. Now what happens is there is no real, purchase request. Every week the artificial intelligence AI sits in Amazon, look at the market price for $10. Let me keep it $11. Next week that fellow will make $11.10. He will make it $1 more, $12. You know the current price of the book? $41,456.70. Think about it, you want to buy, what will you do? You don't even know this, right? There is no intention, it's not there. There is no real intention for them. But collective learning is another area we need to. Okay? Just give me 5 minutes and then I take a break. Because I'm just bringing it to my lecture, right? I just ask you the motivation and the biggest problem is When I asked the question, Madam mentioned about context, right, and semantics, right? Now you see, this is our apple, okay? The apple is seen in the RGB camera. Same scenario, I'm seeing it in infrared camera, right? What happens to the context or semantic? Am I able to see semantics here? No, I can't see the color. Right? I use semantic when I go into a different spectrum. Think about it instead of IR if I go into some other spectrum. Right? I'm not even able to see the semantics there. But what I can see, RGB cannot, I can see the hotspot. I can see whether the engine is on or not. Or I can see the car run for some distance or his car is stationary by looking at the heat signature. Right? A different spectrum sees different information. They see some common information. I can see the edge. I can see the edge here. I can see a texture there. I can't see a texture there. Right? Human spectrum changes, you lose semantics. But you get something else. Now somebody says, I want to learn to detect the car in IR. How do you do it?
That object you can make out clearly in this thermal image, IR image.
Correct. It's a human you are saying. But how does the machine know? You can even still say this is the bus. Right? But for that to see bus, some texture of the bus, it's not there for me. I can't do the knowledge directly from here, distill and give it to IR. I cannot generate an IR image because I don't know what IR can see on itself which I can't see myself. You understood? So generative AI, when we talk about it, it's data driven. What IR can see. I give an example. Right? Same image, optical image in the night. I lost semantics again. Because there is no visual light impinging on a body and reflecting it back. It doesn't. It's like this. Electricity is gone. Luckily, Karnataka, it doesn't happen that often because there is surplus electricity. Hopefully, it remains for long. In the middle of the night, no electricity. How do you navigate yourself? You approximately know the area, right? You don't really need a vision. You use other senses to navigate. Because you know the area, you know everything is kept in the place. You navigate even in the blind. Right? But you don't really know how does it look like in a new scene. Right? So, information in different spectrum gives different information about the same object. We call those, right, humans are different. Person is the same. Right? There's a philosophy in Hindu. Right? I reflect the same thing, but you see me different.
Perception.
Perception varies. Perception varies in a spectral domain too. All right. I have seen Bangalore rainy. I have seen Bangalore smoke and foggy. Have you seen Bangalore snowing?
Yes.
What happens if it snows? What will you do? Think about it. No? When the domain changes to something else, the Bangalore that I remember in 99 has a lot of roundabouts. Right? Many of you agree with me, right? There are the roundabouts. It's all gone. Right? It used to be smooth. At 8 o'clock, Bangalore goes silent, except the MG Road and Brigade Road. Now, Bangalore never sleeps. I see the Rameshwaram Cafe and Bangalore Cafe goes up to 2:30. People are still there. They are like a Mumbai now. Right? What I'm trying to say is, domain changes, it's very difficult for us to figure it out. Can you see anything here? Can you see anything here? But a human will be able to make out because I am looking for something which is precious to save. And how does the machine know what is precious here? That's where you have PLM comes into picture. Vision language model. You can ask the query to the, give the image and say, what is an interesting object? Right? You ask the same question. What do you want to say? It will give different answers. It doesn't understand semantics. It doesn't understand the context. In what context you are asking, it doesn't know. Right? It gives the answer just like that. That's the thing you need to understand. So that's all the problem. Now viewing angle changes. I'm saying from top view, slant view, side view. Object is the same. My perception changes. And knowledge is different. Acquired knowledge is different. How am I going to understand? Can you say, no, you have to always use only this camera. And you have to make sure that this LED lights is what you should use. Then only it will work. I will not buy the car. As simple as that. Right? So those are the problems for AI. The issue is data is not present. Right? Data is not there. AI data is not available. Somebody says I want experiment data. It's not there. What will I do? Absence of data is also going to be a problem for me to learn. So I talked about continual learning. Right? There's another philosophy in AI, zero-shot learning. Have you heard of this one? Zero-shot segmentation, zero-shot learning. Do you know what is zero-shot learning? Zero-shot learning, without giving a sample learning. With one example, I just start the lecture with a half break. Let's see. How many of you know dragon? What is a dragon? What is the feature of a dragon? Mythical figure, right? It has a thick skin, right? Kind of scale structure. I am think of a dragon, right? How many of you know lizards? You know lizard, right? What is a lizard feature? Long tail. It takes a tongue out sticky. It can climb on any surface, correct? Do you know Komodo dragon? How many of you know Komodo dragon?
See,
You guys are going to...
keeps on changing color.
Chameleon.
Even for
No,
chameleon.
chameleon. Komodo dragon. It is a lizard. It is a very big lizard. Right? It has a thick skin. Scale structure, very heavy lizard. Dragons are heavy now. Now, you tell me, do you need a picture of it to know? You don't need. Tomorrow, if I show the Komodo dragon, you will be able to identify it. See, you see here, I have a picture. This is the image. Okay? You don't really need, the moment I give a description about something, right? Your brain can reconstruct, right? Language is a token. Token describes certain features. I talked about heavy. Seeing that you understand it's heavy. I say scaled skin. It's a lizard. More than sufficient for you to imagine this. Isn't it? So that's called zero-shot learning. Without seeing, learning what Ekalaeva did, right? Without being physically present and trained, but observation he learned, right? Or description he has learned, right? So that's what zero-shot learning. But zero-shot learning will happen in the basic data. You need to know what is the lizard. You need to know what is a dragon. You need to know what is a thick skin. Right? Scaled skin. If you say, I don't know, sir, what is scaled skin, I don't know what is a lizard, there is no way you can learn come out of it. So basic knowledge should be there about the domain. Without understanding what is the domain is all about, then you can learn. Right? Continuous also you can learn, zero shot also you can learn. You can generate. What actually we did now is, we did generative AI. Okay? This is a classical example of generative AI. The moment I give the speeches, like a language and describing this, right? You have, is a lizard, immediately picture goes. Thick skin, lizards are of very soft skin, isn't it? Thick skin, you just put maybe from crocodile or somewhere you put the skin, isn't it? Heavy, and a dragon. That's it. I don't have to show the picture, you'll immediately get it. Isn't it? So that's a generative AI. But generative AI to work, the domain knowledge should be. Otherwise, generative AI will learn. Okay? So there are aspects of continuous learning, there are aspects of zero-shot learning, requires generation, requires a language to describe the domain. Otherwise, you can't learn. Okay, I'm not going mathematics, I'm just giving you a lot of philosophical examples to understand and appreciate. You want math? I will do that. Okay? So I'll stop here. Okay? We'll come back with a lot of interesting problems where things going to be much more difficult, right? Generative AI happens in the back, but it has a limitation. That's what you have to understand. My purpose of starting from AI to tell you, generative AI requires the domain. If the AI doesn't understand that, there is no way it can answer. Isn't it? Go to ChatGPT. ChatGPT can translate Kannada also, right? Use colloquial Kannada. It will tell you immediately it is a slang. I cannot translate. You understand that? Right? Because it doesn't have that particular domain knowledge of the slang. Why I'm saying is, people speak Kannada and Tulu, right? You go to the slight beat of North Karnataka, so a combination of Kannada and Tulu, their Kannada is slightly different. Very difficult to understand. You go still further to North Karnataka, right? The way they speak, then it's different. You put all this, you just get confused, say that it's a different version of that language. I cannot do it. Right? Think about it, someone like me speaking Kannada. Now not be able to understand at all. Immediately I speak, any other person say, okay, let me talk to you in English or Hindi or Tamil, it's easier rather than speaking Kannada. You are killing Kannada. Right? Like that, they just think, immediately change. Right? So what I'm trying to tell you is, generative AI to work, the domain knowledge is needed. The domain knowledge is not there, generative AI will not work. I give you two examples. One is an IR image. Without even knowing what IR image can do, you just give an optical image to the AI, give me an IR image, what it will do? Nothing. If you have hundreds of IR image, I give it to the generative AI, this is how it looks, this is a corresponding optical image. There is a possibility it can learn, but there also it will fail because none of the image talks about materials. Right? Heat depends on material. You understand? So different material release different heats. That's going to be a challenge for AI to figure out from semantics what material it is. Can optical image can say what material it is? Just semantics can talk about material? No, it cannot say whether it's a plastic plastic or aluminum or this, moment it is painted. Unless you touch and feel. You understand? So that's a problem for here. The translation information, that what we call the domain gap, is the issue. Right? Now, I put it this way. I want an AI, it doesn't bother about any of this, it should be universal. Right? It's like an oracle or a god which is sitting there, you can see everything. Then it can figure it out. You are seeing from human eye. You are seeing from like eagle. You are seeing like a bat. Isn't it? Bat sees the same object. It avoids obstacle. Human sees the same object, avoids obstacle, but what we see, what bat sees are different. My knowledge cannot be directly plugged in now. But object is the same. You understand the problem, right? That is what we call domain generalization. When the domain changes from one to another. It could be rainy season, it could be winter, it could be snow, it could be anything. Object remains the same, or sensors can change. Optical image, RGB, IR, LiDAR, radar. You can put anything in an image. Acoustic. It will also give an image. Right? But they are all different features of the same person. Knowledge perceived will be different on what eyes you see. Right? That gap is the biggest problem in, yeah. Okay, let me stop here. Let's have a break and come back. immediate time and 30 minutes I need to cover a lot more information. How am I going to do? So I just want to start immediately. Okay? Please bear with me. See, I mentioned like generative AI. One of the points she also pointed out. How am I going to do the data if the domain is not going to be the same? The domain is not same. Again, here I just give you an example. You see, this is SAR image, radar image, optical, radar, IR combined. It gives a different information. Radar talks about materials more detail. It can penetrate deeper and give the reflection. Optical doesn't. IR only talks about the heat. Now, all these three talks about the same object. You see what I get here, you see what I get here, what I observe here. It's different. Right? So perception relies on information. If I'm going to talk about generating AI of a SAR image from optical, I will not be able to do it. Because the sensor, the way it works to generate an image is completely different. So you need to understand where to use the Gen AI, where you cannot use. Right? Generative AI will not be able to figure out just by looking at an optical image to IR. Actually, where it can work, where it cannot work. Right? That's what you have to understand. Short range is easier. Moment I start seeing far distance. Right? That's going to be a bigger problem. Because there is a lot of semantics when I'm looking at far, further and further. Right? Because something looks small may look big. You understood? Because your placing angle is going to affect a lot. That's all. Still a perception is a perception. Can I make it happen? Right? So you need to think in that aspect. Now what we will do? I don't get the data. Can I go and generate the data just like that? Now, just think about Operation Sindhu. Okay, I want to generate an AI data to generate where the enemies are going to be. There is nobody who can do it. US can do it. You know,
Satellite.
they gone for war, so many wars. He never went for war. They had Iraq war, Iran. Then with Taliban, right? Now they have so many wars, so they have the data. He did long back before the technology was there when he went for the liberation of Bangladesh, right? Much earlier than that, we have a fight with Pakistan, on the border. You don't even have the data. How does this thing look like? You are talking about missile Pakistan has. How does the missile going to look like? We only have the description, right? Or we have the spy talking about it. Or they have the National Day parade, they're showing the dummy piece. Right? No, I'm not going to keep it like that. In real life, it is always camouflage. So, the domain gap is going to make your life much more difficult. If you think about military situation, think about a human situation, it's more difficult. Earlier, telephone means, where will you find a telephone? Telephones are always in the hall, correct? It's a common area. You never used to keep it in a bedroom. Now telephone is everywhere. Even in the restroom you have a telephone. Mobile, because mobile is present everywhere. People even put charge while showering. Isn't it? So now object presence is also lost. Where the object could be. It's very difficult, isn't it? The barrier that what we had earlier is being broken. Isn't it? So when you have detecting object become difficult, you can't just simply go ahead with the generative. Now I want to have hyper-real simulation. Hyper-real. When moment I use the word hyper-real, it's as close as possible to the real life using the physics. Can I do that? I can create the world. Right? I have few images of them with that I can just make the models out of it. I can put a material characteristics inside. I can create the world as close as possible to real and start getting data. But still, it is simulation. Simulation is never a real. Just simple example. Think about it today you are coming, right? Because it rained a lot on the previous day. And suddenly sun started coming out. You have a fog-like scenario, right? Your image that you captured is going to be different. Simple, you are cooking. And you are wearing a glass and cooking, right? And you are just spraying water on the top of the tawa. The vapors come and settles in your eyes. Your perception gets affected completely. Isn't it? So, real data is going to be different from the data that what we see. Think about a car, you are going and in front of it you have a BMTC bus. Okay? You just put one push, the black smoke comes out. And settle on your camera. That's all done. All your perception will fade. Isn't it? You understood the problem I'm talking about? So simulation also never talks about the real. There is a gap between the physics-driven simulation model and the images that I'm getting from that to the real. That domain gap is always a problem. Now, this is a philosophy again, right? I'm just giving an idea. Because in the research, my objective is to talk about research, right? I have to develop a model. That model should be independent of whether you have simulation data, whether you have the real data in a snow time, rain time. That gap should not be an issue at all. Right? With a small perturbation, how many of you know control theory? We talk about robustness, right? Robustness. So I look at a virtual domain, like God, right? In question whether it really exists or not. I don't know. I don't have an answer to it. But there is something exists which can see everything. Optical, IR, radar, sound wave, we can see entire spectrum. And that's the knowledge I want to go. How do I go? I see only optical. I try to perturb myself. In a way, I reach ultimate perception. Right? Ultimate intelligence. Right? That's the research direction people are. I do it in a way, I am robust to any change in domain, any change in signal. You can ask me a question. Are we there? No. But that's the view, that's the vision, right? That's the ultimate goal. I want to build a perception model, looks like a God. It's robust to any change. Okay? That's the direction. People will say, okay, let me use generative AI. We talked about generative AI in the last 2 days. My students talked about it, right? I want to give a different perspective. What I see, right? The idea of Manjunath who's sitting here did this work. Okay? He gave this AI and he gave IR, synthetic IR, and this is the real IR, trying to generate the data as close as possible. Now what do? We use a lot of concepts for style transfer. We transfer the style from one to another. The problem is when you do all these style transfer and all this, you still don't understand what this sensor is doing. What am I seeing? Right? Sensor will not see the same style. You see,
what I'm trying to say is I can have a car with a plastic body, with a red paint. I can have a car with an aluminum body with a red paint. I can have a carbon fiber material with a red paint. Right? You just transfer the stain from that red car and a plastic to any other car, it doesn't work. You made out different things. How do we get that in? That's where it fails. If I have a car which is made out of aluminum body and painted red, and suddenly I see a green car which is also made out of aluminum body, I can do the style transfer. It works. The biggest challenge is most of our engines are in front, right? If you have a petrol and diesel car, you will see some of the has engine in the back. But if you have an electric car, where is the engine? There is no engine. You have a battery at the bottom. Right? Every motor, every wheel has a motor. What will I do if I do a style transfer? Just think about it, no? Two cars are there. One is an electric car and another is a petrol car. You do a straight transfer from a petrol car to an electric car in a IR domain, you will show there is a heat in the frame. There is no metal there. There is no engine there. You have to open an electric car, it also has the same shape. But there is nothing there. When I say nothing, there is no metal to generate a heat. Right? You have an auto. You have an electric auto. The buggy, right? Or the Mahindra car vehicle is also like an auto for me. Right? Auto engine is in the back. It shows the heat. If I do the straight transfer to this, I show the heat at the back. But it's not in real life. When I take an actual image with IR, it's not there at all. You see a problem? That's the domain gap where generative AI are struggling today. Right? Now, how do I solve this? That's where language comes in. That's why the prompt engineer plays an important role. What is the quality of a prompt engineer? You should be an expert in language to describe items in nice tokens. If you can describe it properly to AI, see, it is a car, it's an electric car. If you say it doesn't understand. You can say it's a car, but engine is not there in the back. Then when I do a style transfer, I may remove that particular reflection characteristics in that particular car. You understand? So that's where language and vision comes together. Right? To describe things in a manner you can interpret. Okay? Now, language and vision is sufficient? No. I need sound. All senses are very important to talk about an object, isn't it? Sound talks about different things. Sound says you just sit in a petrol vehicle, sit in a diesel vehicle, sit in an electric vehicle, you'll find the differences. Isn't it? If I have that sound, I can describe even better things that we cannot express. That's why I took an apple as a beautiful example for you to understand. Right? We have all the senses to identify that item as an apple, but we really don't know what to talk about it. Whenever I ask you to express, you always express from visual. Right? The most fundamental answer is apple is the edible item, but not all edible items are apple. You see, a problem comes, I need all my senses to identify the item. I can make a guess if other senses are not there, based on the probability of how the item can describe in that particular sense. Okay? Generative AI is a long way to go. You have not integrated many of the information together. The beauty is we call theory of mind, right? Mind is very difficult to understand. Okay? The way it interprets things also is difficult to understand. What is easy for you is what's difficult for me. How do you describe that? It's very subjective, very relative. Okay? So generative is a long way to go because we will not use many informations today. Now there is another model, they might talk about it, right? Now AI itself is one twist. I don't want to go to different spectrum. Low resolution image versus high resolution image. What is that high resolution captures? Can you be very precise?
Clarity, but it occupies more space.
No, all you are saying, smaller detail, clarity, all correct, but can you be precise? Sorry, can you? Borders of the image will be clear, but be precise. I'm just talking about something very unique in high resolution you can pick, whereas you don't get that in low resolution.
More data.
Huh?
Very low.
Distance.
No. Sharpness has the fundamentals of everything. See, for me, everything is signal. Okay? I am a signal person. Distance between the pixel will be less, but that captures some unique aspect of the signal.
Features.
Right? That's right. That feature has a, see, look at a signal. Signal is what? Okay, I give a classical example of baking a cake. Cake is an end product. Okay? My Laplace transform talks about what is the cake contain. Not just contain, it also tells me how much amplitude it has, right? How much quantity of sugar, how much quantity of the flour, how much quantity of the syrup, how much quantity of the flavor. It gives you every signal and their amplitude. That's the beauty of Laplace transform. It talks about every signal contained in the cake, in what composition it is present. That is why we say Laplace transform is interpretable. But Fourier transform doesn't exist for every signal. Why? It tells you what it has, but it doesn't tell you how much quantity. I gave this example because baking, you mom bakes and you bake the same thing, you don't get the same taste, same flavor, same texture, because you don't know what is the ingredient. You go and ask your mom a recipe. The difference between a recipe given by a chef and a mom, she will say put a pinch of salt. Can you tell me what is a pinch of salt means? Isn't it? You add salt, right? The biggest problem in cooking is ingredients, nature changes if it picked up from a different area. You have a very special dosa, right? The urd dal comes from one particular district, has a very different flavor than any other urd dal you get in South India. That's why you are what they call kaldosa, I forgot the name. It has a different, unique, sweet texture to it. If you don't use that ingredient, whatever you make dosa, it will not be look like the same. You understood? So, when you change the data from lower resolution to higher resolution, you are trying to see high frequency features, high frequency signals which was lost, right? Which was not important for me earlier.
That is higher frequency is university
Oh,
time
that
is very closely tracked.
Not only closely
Minute
tracked,
features.
yeah, it not only closely tracked, it also talks about information which is very minute changes. The changes are very high frequency, I mean very rapid, right? If you look at face sometime, it's if you look at the AI generated face as a normal human face, the color gradient is not uniform. The moment you give a AI generated face, you can sometimes even identify that if AI doesn't really take care of the color gradient which is present. You can never say a particular person has one particular color. You understood? Think about it. If you are going to an airport, Bangalore airport, I give an example. You have a DGR. Most of you will be having a DGR, right? Try this out. Previous night, don't sleep. I'm not joking. Don't sleep. Okay? And you have hot shower. Okay? You go and stand in front of the camera, it will not recognize you. If you don't sleep, your eyes will become puffy. And on top of it, hot shower makes it even worse. AI doesn't have any idea. And that person will stand out. Right? You'll do that. I tried it by myself, that's why I'm saying. Okay, so what it really means, those are the features which is very commonly present. You need a higher resolution camera, proper illumination to get the reflection of it. Okay? In human it is the material, right? This is more skin is uniform. Think about the material. It's not going to be uniform. Right? My mom has a nice geek or a spoon, right? I'm still there with me, it's 45, 50 years old. But I go get a new spoon from the market, it's not even come for 2-3 years it goes. The quality of the material has changed. Right? We talk about new combinations. I only know about 917 in gold. Now they are introducing new combinations on gold. Right? So characteristics of material changes, then every other phenomena will change. How bright it will be. The silver, gold silver is still just, not losing its color. The new silver you buy from the shop, it doesn't stay. A few days it becomes very black. Right? You understand what I am trying to bring up? That's the thing. High frequency component is there in high resolution images. So, can I go to super resolution? Now the question comes, why super? Hyper resolution. Much more detail. How do I get? See, when I talk about Oracle and God, God can see every signal, every variation, every perturbation. That's our philosophy, right? Which is true. Every object has the variations. Can you capture the variations accurately? Then you can identify the object very precisely. So, hyper resolution I have to go. That's why I use the word hyper simulation environment. Hyper sim. It's a simulation, but it's hyper real. Which means I have all the signals with me. Why simulation? I can go and hit anybody. Nothing will happen. I have the data. But you tell me how you can respond to it? I don't have it. What I have is only passive system, not reactive system. The moment I come closer to you, your response will be different. Depends on how you made up of. Right? I don't have the data at all in hyper simulation. I can't model all the agents. You understand? These are the receptors. Okay? This they would have talked about, I've given an example, I'm just pitching a different view here. Generative AI. They talk about diffusion models and all that, right? Think about it. This image, doesn't it look like a noise? Why we have a difficulty in hearing? Because the variation in tone, variation in signal is a factor which I want to take interpretation of what you are speaking, isn't it? Suddenly someone on outside is just speaking, right? You speak, the wind blows. I am not able to hear what you want to say. More than that, I am tired and fatigued. My sensor doesn't pick it up. You understood? So, the data in acoustic is more noisy in nature. The diffusion I talked about in image frame may work beautifully, but it comes to a noisy environment. How's it going to work? See, interesting philosophy in diffusion, and if somebody working in cybersecurity will just figure it out. What is here? Secure image means what? Security means what? Data should look like a noise. Correct? You know, famous Elena image, there's one girl's photo we call Elena, right? It's all being used for image encryption, data encryption. You encrypt some data as a noise, nobody will be able to figure it out. What are we saying in a diffusion model? You take an image, make it noisy, till it becomes true noise. From true noise, I will record the original image. What does it mean in data security?
For
There
other
is no
things,
security,
it's like
right?
noise.
You give me a noise, I figure out what is inside. So, the point you need to understand, data security people talk about true random number. There is nothing called true random number. Whereas image, when we do diffusion, we never talk about true random number. We randomize till it is not interpretable by us, not by the machine. You understand? Yeah. Machine still can figure it out, but you can't understand. You can't see texture. You can't see semantically. That is not the true random number. Right? If it's a true random number, there is no security in the world. Anything will be well decimal. You understand? So that's what I want to say. Acoustic imaging, if you take, that's a noisy image. Use of diffusion model in a noisy image is a challenge. That image doesn't have a noise. You really don't know noise comes due to your addition or it is sensor. Okay? Why should I talk about this? Okay? But I'll give a different perspective here, you see. Here object is moving. Smooth. We are stagnant. Right? Same car, same thing, behavior is different. If you don't have the temporal information, you'll never be able to make out what is the difference between this traffic and this traffic. If you are static image, you say, oh, that's great. See? The time makes difference. Think about it. Whenever we do autonomy, whenever we do something, always look at our perspective. Okay? We not think about other agents which is present in the environment. They do react, no? They do respond. Their reaction and response will affect your actions too. At the end of the day, AI is required for making decisions. Right? Suppose AI says, now you safe to take a right turn. But I am coming at very high speed. I am an experienced driver. Will I put a brake? Never. Right? You understood the context I am trying to bring up? So, the temporal information is going to help AI to figure out context is different from action. Right? Is the action, is the normal or abnormal to find out, you need the temporal data. Not just the temporal data, you need to predict. Let's say I'm walking like this. It's easy for you to make out. Now, tell me what will I do? I might even go, stand, turn like this, because you cannot focus in multiple items. You understood? My action depends on what I have in my mind. Phone is one problem. Think about it, today your principal called you for a meeting. And somebody says, no, we are trying to fire staff. Done with it. Isn't it? Your mind is somewhere else. Your action and reactions are going to be different. It's not going to be the same. If human and autonomy comes together, the behavior pattern is going to change. The behavior pattern is important for AI to make a decision. For that, I need a temporal data. I need to predict what's going to come, what image I'm going to see in future. Okay? There are new areas of research. We not only look at generative, we also look at reconstruct. Reconstruct the scene. It's about almost 2 kilometers across 2 kilometers region. We reconstruct the entire area in digital plane. The size of this is just only 100 MB. But images that what we have are 2 terabytes. I have every features here. What is the feature we are talking about? That's what I say, human navigation comes into picture. Even in a night, is still able to make out as long as our feet doesn't drop in the floor. Right? Because we have spatial information about the entire region. Right? I can localize myself and then navigate just like that without even touching anything, without seeing anything. Right? So this is where people are moving. 3D reconstruction. Hyper-real reconstruction because it's a real image. But you tell me, I reconstructed at some time, I'm going to the same location after some time, or some years, it's going to be the same. There is a change. The change will be gradual, change will be drastic. How do I identify? What remains same is a classical thing, right? I just give an example. Usually, you want to give a, let's say your husband or wife coming to see you. You have to give a direction for them to reach the college. Reaching your college is not that easy. Right? I don't see a landmark here. For me to tell them. How will you do that? Right? You see the changes in your area is drastic and that will also affect you significantly. Okay, so this area, not only for navigation, it is also helps me to analyze the core information change direction, right? And navigation inside the space, planning, where to place a road, how much road has been constructed, how many concrete building has come, how much of vegetation is lost, all that I can compute in one data point. Right? So that's an interesting application. You can't get the images. See, it's a generative image. And using this and generating the 3D structure of it. Think about it. We all talk about 2D image generation. I'm talking about a 3D image generation. You want to find out the production of grades in a form, you can take picture in every angle and do the segmentation. But the moment you do 3D reconstruction, it is much easier to collect how much of data you want and whatever angle you want. Right? So, my estimation of production will be much more accurate than actual images which you go and collect the data. Because I reconstruct, then I go in a nice raster scan to compute. Okay? So that's the beauty of 3D reconstruction. The world is moving towards this. Why? Not only reconstructed, this is my hyper-real data. Right? Hyper-real world, where I can change something. My data is much closer to the real world. You understood? Same location. Right? Two different types. New digital model, old digital model. much change really happened. It's a 3D generation. Generative AI only. Yeah? What we call as a nerve, right? Gaussian pattern. You move to a different domain space. I can generate a number of images from here. I identify something as constructed, not constructed, how much is constructed, how much vegetation change, how much is the road structural change, I can find out. Because I'm just connecting this spatially, temporally, and three-dimensional plane. Image is two-dimensional. Now I have a three-dimension, I can rotate. I can see from different angles, which was not possible here. AI is giving me 3D hyper-real data now. And the data is compressed in a form where I can do what I want. Okay? This is also construction. 3D reconstruction of the entire region, not just by camera, by LiDAR. I can see how my interiors are changing. I can find out the entire building is reconstructed. LiDAR images of the image. Right? I can see corridor, I can see platform, I can see the steps. I have the digital world of my own place where I am living. As close as possible to the real. Right? That gives an edge for us to create a perception because I am bridging the gap as close as possible. But still, change I am not able to figure out where the change is going to. See, I can keep a cup here, somebody can keep the cup somewhere else. Right? That change I can't figure it out. That's why I said that required behavior pattern, which means temporal data needed. Okay? That's the research direction. Why I'm saying this in this video plays. If you look at this, I have accelerometer data, I have the map, I have the image, I have the IR. Why do I need all this information? To find out is the road is traversable or not. Right? Classical example in Bangalore, when it rains, you are going to go into the there is no guarantee that you will not come home without falling. Because you don't know where is the ditch, where is the hole, how deep the hole is. Right? You have no idea about it. Traversable path requires not just vision, it also requires an accelerometer to figure it out. If the road is soft, you can't traverse. You need a hard road. Hard road will become bumpy. Sometimes it's preferable when it rains because you can station it. Soft road, you can go down. So to see a problem of what I was telling you earlier, generative AI requires all form of signals to combine. Then only you can talk about whether the road is traversable or not. Right? Second biggest problem, prediction. We all know astrology is never accurate. Right? You can never predict your future accurately. Not possible. You can only guess. But without knowing the future, you can act. Right? Isn't it? Why we are saying this particular period is uncertain period? We really don't know what AI is going to change. Isn't it? Is going to take away all the computer job? No. Is it going to make the programmers vanish? No. Right? We don't know. Right? Yes, it can. Because you can just go to ChatGPT and say, give me a code. For this, the input condition is the output condition. It will give you a code. But is that the right code? It doesn't know. If you don't give your functional requirement properly, the code given by ChatGPT is going to be bad. Right? So that's the world we are moving in, that without knowing the prediction, I don't know the behavior. If I don't know the behavior, I can't act to it. Classical story, we talk about it, right? Somebody once came to someone sitting there, he came to him, how much time it will take to reach the village? He did not respond. He asked twice and thrice, he got irritated and he started walking. Then he called him and said, 10 minutes you will reach. And people have told me earlier, but I don't know how fast you will walk. Isn't it? That fast is also depends on intention. That's a very important aspect. I will give justice to one other aspect. Career path. What I need a mathematical foundation. If you don't have the foundation, it's very difficult. You need to have code, AI, ML, algorithmic knowledge. Right? Programming. You know, ChatGPT can give you a schematic. Interfacing, that's why I use the word deployment. Deployment engineering is what I am looking for. Code anybody can write. Can you deploy? Deployment requires interface and connecting things together. No? How do you connect it? That's where the things comes in. They need to have an idea about cloud. Half the time I'm going to use cloud. I need to know how to push my data in the cloud. I need to know how I use my data to infer. I know how to interface the actions to the real world. Cloud platforms are also very important. If you want to work in companies, if you don't have research exposure, you don't have a job in AI. What I meant is, someone has already solved the code and you leave the data set. Right? You use the data set and run it again, you only know how to run it. That's a requirement. Choices are there. I don't want to read through. But this is a very interesting job profile. Prompt engineer. You see, our skill I'm just writing domain expertise. People think electrical engineering, mechanical engineering, civil engineering, managers. No, they will be more prominent because they have that domain expertise, domain knowledge. Is it a vibration data, vibration of a fan or vibration of a boiler? Vibration of what? Why does it vibrate? Right? That knowledge is key. Not just that, you need a strong language and reasoning skill. We always say you're an engineer, you don't need a language, you need to know engineer's language. Right? No. You need to have a strong language. Why is it strong language? Right word is important. Right word describing the characteristics is important. Right? Everybody looks for it. I'll just give a conflict. Right? Man and women live together in a house. Men like a dog, women like a cat. Dog and cat cannot live together. But when there's a man and a woman, cat and dog live together. You see the paradox? But how are you going to handle it? Right word is important. So, those who are working in research, you need to have strong language skill, strong reasoning skill. That's why I mentioned students should have research exposure because reasoning comes from the exposure. Right? Every course should have a project, and the project we are looking for reasoning, not the report. Then you can get the prompt engineer. These skills are very common. But if you want to be a product developer, you need to know application. Okay? This is very important. Okay? Domain specific AI specialist is what people will be looking for. A computer scientist going and doing a healthcare, or biomedical engineer doing in healthcare, AI. See the difference. Okay? Domain specific knowledge is also important. Okay? So this is a career path. I thought I could do the best way to summarize. Maybe there are some other skills I left out, but this is the maximum I see it now. Why? This is my last slide. Because we are weak here. I don't know, maybe we will go to strong air, like you and me. If we go to strong air, I don't know what we will be thinking. Okay? But it will take long time. Long way to go. I explain you why. Right? Unless AI is able to fuse all the data. Vision and language only combined. That's why BLMs are driving us crazy. Think about it. Vision, language and audio combined. Vision, language, audio and touch combined. 4 senses. The 5th sense. How about the 6th sense? Thinking is not there in AI yet. Right? When I say thinking, I'm talking about meta-learning. I'm not talking about cognition. Cognition is there. Meta-cognition is not there. Think about what we have. Meta-cognition. We can identify what social, right? Learning from social, learning from self. We have all the capability. But meta-learning is still not there in AI. If that comes, we will have capability of thinking like humans. Long way to go. Maybe those job descriptions I mentioned may stay for another decade. Maybe the decade is no longer 10 years, maybe it's 5 years. Right? That's the future. I just want to thank many of us, my team, large team, about 50 people. All the research I'm talking today is because of them. Okay? Without them, I'm not here. Okay? And not just them, there are many research labs behind, many companies which helped me to realize this. Okay? I'd like to acknowledge both of them giving an opportunity to give a talk. Thanks a lot for the college also. Thank you so much. Any question is there you can ask to join. Any questions there? Yeah, that's what it is. If you have any questions, please. Or, you know what is the important information in my lecture? Can anybody tell me what is the important information in my lecture?
Yes.
Huh?
We are smarter than yes.
No? Huh? No? No?
Think of different perspective or different spectrum.
No.
Combine all those things. Multidisciplinary.
No?
I thought it covered many things.
So the best information is my email ID. Isn't it? I am one click away. If you don't know this, I am nowhere at this. Okay? So any doubt, any question, reach out to me. Okay? Thank you so much. Thank you.
Thank you, sir. Thank you for accepting our invitation. Thank you so much for giving session on detail.
You can stand there so that you
One row back with one, we'll stand. Indoor.